Hi guys, I have an easy problem for you today. Let's say we are given two functions, f and g, where f of x is equal to the square root of the quantity x plus 1 times x plus 2, whereas g of x is the product of two radicals, the square root of x plus 1 times the square root of x plus 2. Now the question is, are these two functions, f and g, the same? Explain. You can pause the video and see if you can solve this critical thinking question. Now let's solve this problem together. Let's analyze the two functions. Notice that the quantity x plus 1 and the quantity x plus 2 are common to these two functions. The only difference is for f, these two quantities are both under one radical symbol, the square root, whereas for g, these two quantities are in separate radicals. So how can we know whether these two functions are the same or not? What we can do is we are going to look for their domain. When the domain is not specified whether it's in the set of real numbers or complex numbers, the assumption is we are solving this for the set of real numbers. In order for f to be defined, its radicand, the quantity x plus 1 times the quantity x plus 2, must be greater than or equal to 0 or non-negative. In the case of g, these two quantities, x plus 1, must be greater than or equal to 0, and the quantity x plus 2 must also be greater than or equal to 0. Let me show you first a common mistake here. A common error is, since this value under the radical must be greater than or equal to 0, many students would say x plus 1 is greater than or equal to 0, and x plus 2 is greater than or equal to 0. And so, x is greater than or equal to negative 1, x is greater than or equal to negative 2 for the first function. Now, this process is wrong in finding the domain of f. So what is the right method of finding the domain of f? What we're going to do is think of the critical points. So in here, the critical point is the value that will make the quantity x plus 1 equals 0, and that is negative 1, and in here it's negative 2. Then, let's draw our number line. The critical points are negative 1 and negative 2. We'll write negative 2 first, and then negative 1. Now, since f could be defined if the radicand is equal to 0, then our endpoints here are included, and so we have a circle here, a shaded circle. Let's take values less than negative 2. Let's say negative 3. Then, we need to compute the value of x plus 1 and x plus 2 when x is negative 3. So at x equals negative 3, this becomes negative 3 plus 1, which is equal to negative 2. We just need the sign. Then if x is negative 3, this becomes negative 3 plus 2, which is also negative. We just want the sign. Then, we need to multiply these two, that is, for the product, negative times negative is positive. So we therefore say that from negative infinity to negative 2, the sign here is positive. Let me make it big plus here. Now, take any value between negative 2 and negative 1. Let's say negative 3 halves or negative 1.5. If x is negative 1.5, negative 1.5 plus 1 would become negative, but negative 1.5 plus 2 would be positive, and therefore the product of the quantity x plus 1 times the quantity x plus 2 at x equals negative 3 halves would be negative times positive, which is negative. So we have here a negative sign. Now take a value greater than negative 1, let's say 0. If x is 0, this becomes 0 plus 1, which is positive, so it's positive here. If x is 0, x plus 2 is also positive, and positive times positive, the product is positive. So we'll have a positive here. Now, since we want the product of the two quantities x plus 1 and x plus 2 to be greater than or equal to 0, then the permissible values for x would be this part and this part. And so, we can now take the union from negative infinity up to negative 2, the endpoint is included, union from negative 1, endpoint is included, up to positive infinity to be the domain of f. And graphically, from negative 2, the endpoint is included, you go to the left, and from negative 1, the endpoint is included, you go to the right. That is the domain of f. Now, for the domain of g, here, we know that x plus 1 must be greater than or equal to 0. So that means x is greater than or equal to negative 1. And here, so we use the word and, x plus 2 must be greater than or equal to 0, or x is greater than or equal to negative 2. So let's graph them. The endpoint is included, and that is going to the right. It's greater than negative 1. And here, x is greater than or equal to negative 2. Here is negative 2. The endpoint is included, and we are going this way. So we have here end, so we are after the intersection, and this part is the intersection, and that is from negative 1 up to positive infinity for the domain of G, whereas this is the domain of F. So are these two functions the same? Obviously, based on their domains, these two functions are not the same. So no, these two functions are not the same. So thank you very much. This is Land Assistant, and I hope to see you again in our next video. Bye for now.